Given that arc AB is 110 degrees and the length of line segment AC is 10, find the measure of angle ACD and line segment AD. When I take a look at this picture, the first thing that I notice is I have two tangent lines that are extending from the same external point, and that's C. And if you have that, you can assume that these two lines of tangent C are congruent. Now, as you can see, it looks like that we have an isosceles triangle. And with that, we can conclude that opposite angles are congruent. We don't know what they are yet, but we can conclude that. One of the angle measures that we need to find is angle ACD. And I know that in an isosceles triangle or an equilateral triangle, when you have a vertex like angle C and you have a line extended to the other side, not only does that bisect the other side, but it's perpendicular to the other side. So we end up with two right triangles. And I'm just going to concentrate on one because they are congruent right triangles. We are told that arc AB is 110 degrees, so that's this arc right here. And this angle right here is an inscribed angle, and it intercepts that arc. Okay, so if I take 1/2 of 110, I end up with 55 degrees. Now I'm able to find the third missing angle because we have a right triangle. We know that the sum of the two acute angles of a right triangle is equal to 90, so 90 minus 55 gives me a difference of 35 degrees. So the measure of angle ACD is 35 degrees, and the length of AD, I'm going to find by using trigonometry. We have a right triangle, so why not? So you could either use sine if you're using 35 degrees, or you can use cosine if you're going to use the 55 degrees. I'm going to go with sine. We're looking for the opposite side, and we know that the hypotenuse is 10. Cross multiply. And we get 5.7358. Now, why did I round to the 4 decimal places? Because I'm using trigonometry. I wasn't told where to round to, so you always round to 4 decimal places. Okay, so this lesson has to deal with inside and outside angles. So these are theorems 4 and 5. What we want to be able to do is find angle measures from chords, find angle measures from two tangents, find angle measures from a tangent and a secant, as well as find angle measures from two secants. So with regard to inside angles, they are created by chords. This is theorem number 4. And they are formed by two chords crossing. So it makes a pair of vertical angles, and we know that vertical angles are congruent. We learned that earlier. Angle X is equal to 1/2 the sum of the arcs that they intercept. So it's the average of the two arcs. So let's go ahead and find that in order to find this angle. So we're going to have 50 plus 20. Those are the two arcs that these angles intersect. So 50 plus 20 divided in half is equal to 35. So X is equal to 35 degrees. I'm also going to throw in some other ideas. If we needed to find the measure of this obtuse angle right here, I'm going to label it y. Angle x lies next to this angle y on this line, and we know that all lines are supplementary. So this is a linear pair. So all I would have to do is subtract 35 from 180 and get what y is. The next thing we have are outside angles, and they're created either by tangents or secants. This is theorem number 5. Outside angles are formed by the tangents and secants outside the circle. So as you can see, we have two tangents here, and we already know that if we do have that, their lengths are congruent, but we're not dealing with the lengths of the tangents. We're dealing with the angles that they create in terms of the arcs that they intercept. So we have a major arc, 220 degrees here, and we have a minor arc, that's 140 degrees here. So the measure of angle x, if you look at this, it kind of looks like the bottom of an ice cream cone. So a lot of times I've eaten ice cream cones where there's chocolate down at the bottom. If you buy the frozen ones in the supermarket, that's that x portion there. So the angle that we're looking for is that bottom portion of an ice cream cone. And the theorem states that that angle is equal to 1/2 the difference of the major arc and the minor arc. So the major arc is 220 degrees, and we're going to subtract the minor arc from that, take 1/2 of it, and get our result. So we get a value of 40 degrees, which makes sense because that angle is definitely acute. Okay, so another type of outside angle we can have created are ones formed by tangents and a secant. Okay, and it follows the same premise. We take the major arc, 100, we subtract the minor arc of 60, so that's a difference of 40, take 1/2 of that, we get a 20-degree angle. So that's what angle P is equal to. And then we also have angles that are created by two secants. (80 minus 30) is a difference of 50. Take 1/2 of that, that's 25 degrees. So angle P is equal to 25 degrees. Here's an abbreviation or acronym that will help you to remember the relationships. It's called CITIO. And what this stands for is central angles are equal to the arcs that they intercept. Inscribed angles are 1/2 the arc that it intercepts. Tangent angles, which are really inscribed angles, are equal to 1/2 the arc that it intercepts. Then we have inside angles that are created by chords. They are 1/2 the sum of the arcs that they intercept. And outside angles are equal to 1/2 the difference of the arcs that they intercept. This is going to have to be memorized. You will not be given any of this information on a Regents exam. You're very limited as far as your resources or formulas that they give you. So I'll just write this really quick, just in case you didn't catch that. Central angles are equal to the arcs inscribed are 1/2 the arc measure. Tangent is really an inscribed angle, is equal to 1/2 the arc measure. We have inside angles, which are created by chords. They are 1/2 the sum of the arcs. And outside angles are 1/2 the difference of the arcs. Okay, so you're responsible for the associated homework that goes with this, and you will complete that as classwork the next time I see you.